This is the Water Quality Association podcast, promoting the betterment of water quality around the world. And hello, I'm your host, Wes Bleed.
Ion Exchange resins are capable of treating enormous amounts of water to very high purity standards. If you look at some of these larger systems that I used to work on, power plants and semiconductors, we're talking about thousands of gallons per minute.
That's Frank DeSilva of Resintech talking about the impact of ion exchange technology for water treatment. And welcome to the WQA Podcast, the weekly podcast from the Water Quality Association, the leading voice of the residential, commercial, and industrial water treatment community. Find us at WQA.org. If you're joining us for the first time, we're so glad you're here. Be sure to subscribe and like the podcast so that you never miss a show. That's the magic of podcasting. And be sure to share the podcast with someone you know. We also feature our podcasts on YouTube. Go to youtube.com/@Water Quality Association videos. Our guest on the WQA podcast is Frank DeSilva, Technical Advisor for Resintech and immediate past president of the Pacific Water Quality Association. Frank touches on some very informative topics, including his journey in the water treatment industry, a basic understanding of ion exchange technology, which I think you'll find helpful, problem solving and innovation in the water treatment industry, and then what he sees as new opportunities for point of use and point of entry technology. Later, we'll have our WQA tip. It's all coming up on the Water Quality Association podcast. Frank DeSilva joins us now on the WQA podcast, a longtime WQA member and really a great friend of the industry. Frank, great to have you on the program.
Hi, Wes. Great to see you. Good to be here.
Hey, we just touched on your title. I know your career has spanned multiple decades, in fact, and you're now in sort of a semi-retired state. But could you just kind of back up a little bit? Tell us about your pathway into and through the water treatment industry, how you got started, and what your journey's been like.
Sure. I graduated from college in 1978 with a degree in environmental science. And I immediately went into a field of water treatment. It was more on the civil side. And that eventually led to me getting a job at a facility that had an ion exchange system to treat plating waste. Big, large system. And I was an operator. Blue-collar worker, and I was found by a headhunter when I was working second shift, and I ended up working for Belco Pollution Control, which was an engineering company and equipment provider. And that's where I really cut my teeth on ion exchange. I learned how to build, operate, troubleshoot, service large industrial ion exchange systems. During that time, I was called on by all of the representatives of all the resin companies back then. There was Roman Haas and Dow and Cybron. Those were the three primary companies. Cybron, their representative was Michael Gottlieb. Michael Gottlieb and I started working together in 1989. He started Resintech in 1986, brought me on in 1989. At that time, we were working out of the basement of his home, packaging and shipping resin out of the garage. Bring it up to date now. We're in a huge facility in Camden, New Jersey, employing 250 people and actually manufacturing cation exchange resin here in the United States, which is huge. So during that time, when I went from the equipment side to the ion exchange side with Mike Gottlieb, it was a real opportunity. And that's where I really started focusing on the ion exchange technology itself.
What drew you into that whole field right there? What was it that kind of got you going? I know people talk about ways in which they're attracted to certain aspects of their job. What was it for you?
Well, I guess it was the capabilities of what the ion exchange resin could do. And by that, I mean, ion exchange resins are capable of treating enormous amounts of water to very high purity standards. So if you look at some of these larger systems that I used to work on, power plants and semiconductors, we're talking about thousands of gallons per minute of water production that is essentially ultra pure. So, and it was just a fit. It was very interesting to me. I really had an opportunity to work with many of the icons of the ion exchange industry in the 80s when I worked at Belco. It was from 1980 to 1989. And, people like, Mike Gottlieb, number one, but then other people, the authors of the books that I studied to learn ion exchange. If I can give you an example, here's a book, Demineralization by Ion Exchange by Samuel Applebaum. I had to go to Beijing for a big project for a power plant, and I had an 18-hour flight to Tokyo. That's how long it took to get from JFK to Tokyo back then. I read this book cover to cover on the flight, and the next day at the meetings, I was an instant expert on all facets of ion exchange. It was, I really took advantage of that opportunity. And I'm going to be mentioning reading later on in our talk.
Okay. All right. Well, okay. So for the non-techies, me included, tell us about the role that ion exchange plays in these various environments in which you talked about.
Good. And I want to really talk about the non-techies here. So ion exchange are little plastic beads about 0.5 millimeter in diameter, about the size of a grain of sand. And they start out as inert beads, just, little cue balls, if you want to look at them that way. And they are activated chemically to have an exchange site on and inside the bead. And that exchange site is either positive or negatively charged. So the positively charged beads will attract negatively charged ions, and vice versa. The negatively charged beads will attract positive ions. The most common application, of course, is water softening. So water softening is taking the hardness ions out of the water, which are primarily calcium and magnesium, to a lesser extent, iron and manganese. They are positively charged, so guess what active site is on the cation bead? A negative site. So they work their magic by the electrical attraction. Opposites attract. And once the bead is loaded up with these ions, it can be regenerated in most cases. You treat it with a chemical solution, it lets go of the ions that it's collected, and it's good for another run. And these runs can be hundreds, if not thousands, of times over the lifetime of the resin. Resin will last, softening resin, 8 to 10 years. Other resins, 4 to 6 years.
So it's environmentally friendly.
It sure is. We, reuse, recycle, it's all there.
Yeah, great. Fantastic. Well, I appreciate that. I mean, that was a good overview. And I know you're famous for having a little vial of ion exchange resin in your pocket to show people. It's kind of a fun little thing that you
Well, you should mention that. Here it is, right at my side. I like to carry resin with me.
Yeah.
When I do that quick little explanation.
That's great. That's great.
It particularly comes in handy when we're talking to people that are not in the water industry.
Yes. Yeah, I can imagine. And also handy in terms of just reinforcing what it is what your product does. And it's amazing.
I want to talk a bit about how I got to where I am. So it was a real opportunity, tremendous opportunity for me to work with Mike Gottlieb one-on-one, for years as the company was growing. Now, Mike was up here in the stratosphere, in terms of ion exchange technology. And although I had worked on ion exchange systems for almost 10 years, I was nowhere near that level. I knew a lot about all the different facets of the system, the tanks, the valves, the pumps, and so on, and of course the resin. But with Mike, it was different. It was a real focus on ion exchange technology and capabilities. So what I used to do when we would go out to lunch, for example, I would have one of those little handheld voice recorders, with the little cassette tape. Remember those?
Oh,
I'd
sure.
ask Mike a question. I'd turn on the tape and just let him talk. and then I would transcribe those answers to single page summaries. And those I should interject here. Do you know why they were single pages? Because back then we faxed information to customers. We didn't have email. And it was just
I think I remember those days.
Fast forward, 30 some years, 33 years. And at my semi-retirement dinner at our annual sales meeting 2 years ago, the current president of Resintech, Larry Gottlieb, gave me this. He made a book out of what I called my technical data sheets, which were these one-page summaries of information that I was gleaning from Mike Gottlieb. Isn't that cool?
That is fantastic.
What a resource, because they're one-page summaries. They don't get too deep, but at least it'll give you speaking points and an understanding of, removing gold from plating rinses, how to handle high levels of iron, and so on.
I'd be interested in hearing some of your thoughts on problem solving, how you get into areas where you need to think creatively and think about innovation. Our convention theme next spring is about innovation. So this might be a good springboard into that.
Yes. And what an important question that is, Wes. So let's go back to the first week of August in 1989, my first week working at Resintech in the basement of Mike Gottlieb's home. I get a call from a customer. He says, I have copper in my water. Can you remove it? I said, sure. Copper's, it's kind of like calcium. Positively charged, easy to remove with cation resin. So I asked him, what else is in the water? He said, oh, nothing. Well, guess what was in the water? Calcium, magnesium, sodium, sulfate, alkalinity, chloride, silica. So the beginning of any application, where we need to give a real valid response, we need to identify exactly what is in that solution. Many times, ion exchange is the removal of the bulk ions, such as softening or deionizing. We're removing everything, especially in deionizing. But when we're trying to selectively remove emerging contaminants like PFAS, everybody's talking about PFAS, chromate, uranium, nitrate, arsenic, you need to know what else is in the water. So the very first step is identifying what is in the water. We have water testing capabilities that we offer at Resintech, and so do many other companies. And we do the entire panel. What is that matrix that we're up against? Is the TDS high or is it low? Is the pH high or is it low? What phthalates may be present in the water? So that's the starting point. And that will determine, number one, is ion exchange feasible? Ion exchange has some TDS limits in many applications. It certainly has, or certainly can be limited by the suspended solids that are in the water. So there's a certain degree of pretreatment that's needed. But overall, I can't overemphasize the importance of a thorough water analysis to get that going.
Was there a memorable challenge, similar perhaps to what you just explained, where you had to take something that you really didn't understand at first and then, got your arms around it and figured out a solution?
all the time, all the time, because the softening and the deionizing, those are fairly simple applications, but as we delve into these other applications that are drawing attention now. Stormwater is one. Rainwater harvesting, another. Construction dewatering. Let's talk about construction dewatering for a moment. So out here on the West Coast, you dig a hole to build a skyscraper or a parking structure or whatever, and you'll get infiltration of water. The water might be collected rainwater. It can be infiltration from the surrounding bay. So one that comes to mind, and this has happened several times, in San Diego County, any construction that's done near the bay, and we have plenty of bays here. We got the lagoons and Mission Bay and so on. But those bays contain copper that is a legacy pollutant from the hull paint of marine vessels. The Navy's responsible for a lot of that. The copper sulfate that was in the paint is an anti-bacterial growth, algae growth. So anyway, you dig a hole. Before you can pour concrete, you have to get rid of that water. Even though you didn't put the water there, and even though you didn't put the copper that's in the water there, you have to treat it to get the copper out. And for whatever receiving body of water regulations there may be. And almost any place you send it, they don't want the copper in it, whether it's going to sewer or back into the estuary or the lagoon. So that was a real challenge because the bay waters are brackish, very high TDS, lots of sodium, lots of calcium. pH isn't ideal for selective removal of copper using a heavy metal selective resin, but it worked. We piloted it. It worked, and now we've used it in a number of cases where some very large projects were potentially going to be held up because they couldn't, discharge this water to anywhere. Many of those projects are subject to liquidated damages if they're late, $10,000 a day or whatever. So the economics change. And the ability to selectively remove that contaminant, keep that project on task and on time is big for the contractors and the regulators.
And then what about documenting all of this and then sharing what you've learned? And how does that help others in the industry?
Well, it's some of it we can share the details, some we can't, because sometimes a project doesn't want everyone to know that they encountered copper as part of this project. Many times it's an unforeseen circumstance with these contractors. But as far as helping other customers, we maintain a vast database of what are called the selectivity coefficients whenever we come upon these types of applications. How much does the resin like copper? Well, we know how much the resin likes copper in a standard water, like that episode that I referred to back in August of 1989. We know how copper will behave in ordinary tap water, but in high TDS, we didn't really know. But from that application, we're able to glean the effectiveness and, most importantly, the capacity, because the customer needs to know how long that resin will work when it's out in the field.
Sure. And then you're also a speaker and an educator, and you.
That's right.
So you're able to share your knowledge that way. How has that shaped your career?
That's one of the favorite things that I've done over my career, was to get up and talk about these applications at different conferences and training situations. And people who know me know that I insist on having a whiteboard at my disposal at trade shows, for example. And many times when we'll go to an architect engineering firm or something like that, and they're expecting a canned PowerPoint, I initially disappoint them because I tell them I want a whiteboard. That's where I want to go. And so my style, I really want to direct the information I give to what the people in the audience want to know. So I'll begin with a big empty whiteboard, and I'll just start peppering the audience with questions. And you've seen me speak. A lot of my speaking is questioning.
No.
I'll make a list of what they want to know, and then we just attack it. And again, throughout the talk, I ask questions of the audience because they know more than they know. And I like to point that out. So it's a lot of fun. And, sometimes I'll bring a call bell and I'll give that to somebody in the audience. And whenever somebody gets a question correct, the bell gets rung, they get a Resintech hat or a piece of candy or something. I like that two-way communication style of talk that I give. It was difficult when COVID started, where I had to speak to a screen because I can't see the feedback. I'll see some chat questions come up, but I don't know if my jokes got a laugh or it's not as much fun. I'm so happy that we're back to personal meetings, in-person meetings.
No question about it. Hey, how about your work with standards for Ion Exchange and how important those are, and are they where they need to be, or will they be evolving?
So my work with the standards, my most important work is I'm on the Ion Exchange Standards Committee of the American Waterworks Association. And we're writing up standards now for the use of ion exchange resins in municipal drinking water systems. There's no standards written for that. And the standards aren't necessarily hard and fast. They're a guideline. Because for many municipalities, this is the first time that they'll have an ion exchange resin system on property. They're used to clarifiers, filtration, carbon filtration, but not ion exchange. And ion exchange is being used more and more for the treatment of these groundwater sources that the municipalities draw from. And why is that? Because as drought conditions and climate change, lower the groundwater and just make less drinking water available, these previously locked assets that were contaminated groundwater aquifers are being looked at more closely because, hey, even though that's got arsenic in it, we know how to treat it. We can use that as our drinking water source. And the same goes with nitrate, chromate, uranium, and now PFAS. And PFAS is being found in almost every place we look for it. And all of these emerging contaminants are easily removed by ion exchange resin. Some of the applications are regenerable, some are not. So in the standards we're writing, we're addressing both of those types of applications. The long life, non-regenerable systems need to be carefully designed because you're going to have resin in the vessel, in the field, treating water from 6 months to 2 years. So there's things that you want to make sure that you do to preserve the life of that resin. If you let some suspended solids in there over the course of between 6 months to 2 years, you're going to possibly plug up that bed. You'd surely increase the pressure drop through that system. We're talking about big vessels, 8 to 12 foot diameter. There's a lot of motive force required to push water through those vessels. If you increase the pressure drop, your cost of providing that purified water goes way up, the energy cost. So the standards address that. Aside from that, other standards that we're looking at, not so much written standards, but written application notes. But the real standards work that I'm doing is with the American Waterworks Association.
Okay. And then it sounds like there's a future for ion exchange, but are there new ways in which it will be applied, do you think, or will there be new opportunities?
Yes, there will be opportunities. And let's talk about PFAS again. And I haven't identified it, but PFAS is called the forever chemical. It's perfluoroalkylated substances. It's, used in Teflon, one of the big contributors to the pollution in groundwaters are aircraft firefighting foam. It's
Right.
used in Scotchgard, it's in carpets, it's Gore-Tex, you name it. We contact it in many, many different levels. Food we eat, but the water we drink. So PFAS. So what do we do with the PFAS-laden resin? This resin's been online for a year. It's collected all this PFAS. What can you do with that resin? Can't really regenerate it, although, we are looking at regeneration techniques, and other companies are as well. And I'm sure eventually we'll see some methods that can be used. There is a patented method right now that uses methanol to strip the resin of PFAS, and then that PFAS goes on to some kind of destructive technology. But a municipal water drinking plant is not going to put methanol on a website, on a well site. That just wouldn't fit. So we're looking at other salts, perhaps, that might be used to regenerate PFAS off a resin. There's some instances where it makes sense to have ion exchange first and then carbon as a polisher for these PFAS applications. And then there's other applications that do just the reverse. First, resin first, and then carbon as the polisher. Depends on the mix of PFAS. There's hundreds of PFAS compounds out there. Every application is a different PFAS soup. Not only do you have a different mix of PFAS, but you have a different matrix. First, calcium, magnesium, sodium, sulfate, chloride, alkalinity that you need to contend with. So we're amassing a database from in the field applications and pilot work, and also lab work that we're doing, analyzing how how effective PFAS removal is under different background matrices. That's the real challenge of really dialing in this PFAS application, getting the most removal you can using ion exchange resin. The ion exchange resin is a much faster reaction than activated carbon. So you use less resin than you would carbon. And if we take that a step further, that means that the vessels are smaller. The contact time for carbon is 10 minutes empty bed contact time. For resin, it's only 2 to 3 minutes. And why is that important? Because PFAS being found, especially in these municipal applications, the munis are big, large installations. Many times they don't have a lot of extra real estate to plot 12-foot diameter vessels in. So offering ion exchange in 6 to 8 diameter vessels is very attractive to them. Lower capital costs and so on.
So Frank, if I'm understanding you correctly, and again, my technical knowledge is very, very low. It sounds like you're saying there are PFAS solutions with ion exchange at the municipal level as well as at the consumer level.
Absolutely, yeah. Now at the consumer level, you can use, at point of use, you can use cartridges of carbon or cartridges of resin.
Okay.
Or even layer them.
Very good. Hey, wanted to get quickly over to you as, in terms of your career, what opportunities you've had for mentoring, either being a mentor or being mentored yourself, and then some advice for future leaders. Can you take a stab at that?
Yeah. Oh, I'd love to. Because now I'm in a position to talk about that. And my mentoring was, through the WQA was really a great experience. I loved working with these younger people and see where they're going because, they'd have some skills that I do not. But one of the things that I really wanted to emphasize to anybody that I talk to that wants to advance their technical knowledge in the field is that over the past 40 years, if not more, I always read. So let me sum it up by saying, don't Google, read. Of course, there's a time and a place for Googling when you need an immediate response to an immediate application. But to really foster a deep understanding of a water treatment system, especially ion exchange, water treatment fundamentals. Whose name is on here? Oh, Joe Harrison. Look at that. Residential water processing. Wes's name is in here, right? Yeah, this is Wes McGowan. Oh, look, I have a signed copy. I would start out with those books. Even though this is residential water processing, it scales right up to commercial and industrial. And the same with this. But I'm a voracious reader. I read like I breathe. And before I would let myself, get lost in my novel every night, I would read a couple of pages of a technical book. And my reward would be the novel that I got to. But the reading really gave me an understanding. And here's another one. One of the study books, Water Processing, based on the writings from Wes McGowan. I have an enormous Ion Exchange library. And that's what helped me get to where I am. There's some industrial books out there, the Betts Water Conditioning Manual, the Drew Industrial Manual. And by the way, these books are all out of print, but you can find them on used book sites for very cheap, sometimes less than $10. And the Nalco Water Handbook. And these books not only have great chapters on filtration, carbon filtration, ion exchange, but they also have chapters on applications, refineries, power plants, and so on. And when I was doing more industrial work, the night before I went into those plants, I'd read that chapter, become accustomed and know all of the equipment that I was looking at. So my advice is to read and really get that deep knowledge and that deep understanding that you can only get from books.
Well, and I'll put in a plug for WQA's training as well, right?
Absolutely. Yeah. It's based on, based on these.
Yeah.
To put it in perspective, I still read the newspaper every day. A paper copy of the newspaper.
Right. I was going to say something you can hold.
You know why? You know why? Because it forces me to read articles I wouldn't normally read if it was just clicking on a title. So it gives me a more rounded knowledge. And, just like, I keep throwing these books up, but just like these books, I read some aspects about treatment that I wouldn't normally read, but look at that. Now I know about this or that.
Well, and then I would imagine mentoring has helped as well, right? And and
it's helped me. You always learn by explaining things. Sometimes you have to study up before you teach it, but it really helps your understanding. And it's rewarding to see someone succeed in their career.
Well, looking ahead to kind of wrap things up, I loved your thoughts on emerging technologies, trends in the industry, something that may be, several years away. I would love to hear your thoughts about that.
I have a lot to say about that, but I won't make it too long. Okay. So what does the future hold? This is I'm just coming off my second stint as the president of the PWQA, the Pacific Water Quality Association. The first time around in 2010, 2011, we were fighting for our industry's life here in the West for self-regenerating water softeners. It was the softener wars. The regulators wanted to ban self-regenerating softeners and not allow salt to go down the drain. Those wars were fought, compromises were reached, and business goes on. So here we are in 2024. We're finding that there are many underserved communities in the Western region that do not have access to safe drinking water. And this may include emerging contaminants like arsenic and nitrate, chromate, chromate, Aaron Brockovich. And what else? Well, uranium and PFAS. finally, after years of work, the regulators are accepting the fact that point of use, point of entry is an acceptable treatment alternative to a large centralized system. If EPA had their way, 5 years ago and 10 years ago and so on, they would want every municipality or every region that has a problem with emerging contaminants to be connected to city water that is being treated at a centralized plant, multi-million-dollar plant with, people with white lab coats and clipboards walking around. But that's just not feasible. The money is not there. So we're working with the California State Water Boards, the State Water Resources Board, on the SAFER program. And SAFER is safe and affordable funding for equity and resilience. It's a 10-year program. $130 million is available annually to address this issue. And it's mostly for communities that have 200 hookups or less. But think about it. If they detect chromate in that water, you can put an RO under the sink, problem solved. All the water for cooking and drinking is now chromate-free. And the same with PFAS, and arsenic, and nitrate. So we're marching down that path. We're working closely with the board and other entities that are offering this funding. The EPA has a program. The EPA has a federal program. When we met with Bruno Piggott, the EPA deputy of water, he spoke at the DC Fly-In this year, and he talked about the program that they're promoting with funding, something that we didn't know a lot about. At the PWQA conference 2 weeks ago, we had an invite we invited a water board that was a nonprofit that helps facilitate these types of programs. And we came to learn these types of nonprofits exist throughout the state. So we're going to be working more closely with them. And another thing that we're doing, what I really tried to do in my term as president this year, was reach out to the other regional organizations that can benefit from point of use, point of entry treatment to solve the problems in their areas. Who did I reach out to? The National Groundwater Association and their regional association, California, Washington, Oregon. They all have regional or state organizations. The AWWA and their regional association. The Rural Water Association. My gosh, talk about a good fit. These rural water associations are made up of these communities that have, in most cases, less than 200 hookups. The Water Environment Federation, who else? The Water Reuse Association. We've also reached out to some industry groups, the plumbers, wow. the Association of Water Technologies, the Stormwater Catchment, Rainwater Catchment. So we expect to see a lot of partnership with them, and what would hopefully end up as a synergistic approach to solve these problems quickly and economically. And that's where the future is, because these areas cannot afford a centralized treatment system. But my gosh, the WQA, the capabilities of the WQA member companies and the PWQA member companies, we have the answer. And it's fast, it's economical. We can solve the problem in months, if not weeks, right, at a tiny fraction of the cost of a centralized system.
Frank, as I'm listening to this, and then I'm thinking again, as I mentioned earlier, the WQA convention will be in California next spring. How important is that to bring the convention back to California for the first time in a while?
I can't wait. I can't wait because, we've been working with the regulators. We've just started working with these other organizations and also the politicians. We had a great speech at the PWQA by Senator Barb Archuleta, who's a California state senator for the sections of LA County and Orange County. He was excited about what we had to offer when, he came to the show and he saw the point of use, point of entry systems that we do. So I'm going to make sure at the WQA show that we get exposure and invites out to those entities that I just described.
Yeah.
It'll be a real opportunity for us and for them. They're hunting around for these solutions. We need to make sure that they know that we are a resource and quite possibly, a solution to their issue.
Very good fit indeed. Hey, Frank, this has been terrific. So glad to have you on the show. Tremendous history that you articulated. So many interesting facets of your background and great application for ideas, innovation, and things that we can take away from our conversation. We appreciate it.
Very good. Wes, always a pleasure.
Our WQA tip, November is Member Appreciation Month at WQA, a time when we say thank you to our members for their important role in the betterment of water quality around the world. Highlights for the month include a volunteer summit on November 6th, a member meetup on the 13th, and a government affairs webinar on the 20th. You can learn more at WQA.org. Thanks for joining us for the Water Quality Association podcast, bringing you the latest news and insights from the association, our members, and outside experts to help you better serve your customers and grow your business. Learn more about water and water treatment at our consumer website, betterwatertoday.org, and learn more about professional certification, product certification, and how you can become a WQA member at WQA.org. Until next time, this is Wes Bleed. So long from the Water Quality Association.